All right, this video is about function notation. Function notation is a different way to write out our equations that's going to be really helpful as we move forward in math and have to do more and more complex things with the equations that we're using. So right now we're used to using standard notation. Standard notation is a way to write out our equations that looks like this. Y equals 2x plus 7. Very basic formula. We have the x as our input and the y value is our output. So I can plug in any x value I want and solve, and it's going to tell me the y value that's my output. Let's just go ahead and take a look at another formula. For the same type of notation, y equals 3x minus 3. Again, we can see that we have the y is the output, the x is the input. Now, standard notation is just fine if you're doing very basic calculations or you're only dealing with one equation at a time. But if we have more than one equation in front of us, standard notation doesn't really help us differentiate which equation is which. I can't really tell which equation I should use for which purpose. So if I say plug 2 into the equation, you have no idea which equation I'm talking about unless I specifically say the equation on top or the equation on bottom or the equation I gave you second or whatever I do to indicate which equation. And it just makes it a little bit more complex to tell the difference between them. The answer format also gets a little tricky. For example, if I have the solution y equals 15, that's all good and well. I know what that y value is, but it doesn't tell me which equation it came out of or which x value I used to find that output. For example, if y equals 15, I could have used the first equation, the top one right here. I would have had to plug in x equals 4 to do it. So 2 times 4 is 8 plus 7 is 15. So I could get the number 15 from the top equation if I plug in the x value 4. But I could also get the number 15 from the bottom equation if I plugged in a completely different number. If I plugged in x equals 6, I could get the exact same answer. 3 times 6 is 18, minus 3 gives me 15. So I can get the same answer from both equations, but I have to come from different inputs. And there's not really enough information here to tell me which path to use or where my answer came from. So standard notation is awesome if you have one equation at a time, but as soon as you've got more than one, it becomes a little bit more challenging. So to get around this, we have function notation, which is a way to tell the difference between functions really easily, just by giving them names. Instead of just using the letter y, I give the function a name, and this name does two things. It helps me differentiate which function's which, and it helps me identify what the input is that I used. So the most common function notation, the most common name for a function, is f of x. Now f of x takes the place of the y value on the left side of my equation, and it means the exact same thing as y. It's still the output. But instead of writing y, I write f of x. So I have the name that I've given my equation. That's the letter f. So for example, this function is called Fred. So this is Fred of x. So I gave it a name. And the x tells me what the variable is inside the equation that I can plug stuff into. So same equation as the top one on the other side, 2x plus 7. This function is now given a specific name, and I know exactly what value I'm plugging stuff in for. I'm plugging stuff in for x. Let's take a look at the second equation. We'll give it another name. Since Fred is already taken, let's go ahead and give this one the name George. So g of x. Different name for this guy. Same equation as the one on the bottom, 3x minus 3. But now it's really easy to tell the difference between these two. Instead of saying plug 2 into the equation on top, I can say find f of 2. And that means take the equation on top named f and plug in the number 2 for x. Or I could say find g of 7, and you know to use the equation on bottom and plug in the number 7. So it tells me which equation to use and what to plug in. Let's go ahead and plug in 2 for f of x and see what we get here. So to find f of 2, I'm going to use the top equation called f, and I'm going to put a 2 in everywhere I see x in that equation. So f of 2, use the top equation, 2 times x will become 2 times 2 plus 7. And we can go ahead and solve this guy. 2 times 2 is 4 plus 7. That leads us to our final answer. F of 2 equals the number 11. And now this answer gives me a lot more information than the type of answer I used to get before. I used to just get a y value. It didn't tell me which equation I used or where that answer came from. But now I get which equation I used, what number I plugged in to get there, and the answer all at the same time. And it's really, really helpful for continuing to do things with this information. For example, this would be really easy to graph because I would be able to see the x value I used, the y value I got as a result, and what the function name is. So I can say that the point 2, 11 lives on the graph of f of x.